In this repair video, we're gonna be working on an LG monitor. LG 5K Ultrafine 27-inch monitor. We have 7 of those monitors in the shop, and we get them in the shop maybe twice or 3 times a week. While the monitor may be awesome, amazing colors, amazing brightness, amazing details, amazing resolution, the monitor is not built to last. People are paying $1,300 for that monitor, and just after 1 year, 1 year and 2 months, 1 year and 6 months, even 2 years, the board is failing. Everything is depending on the input, which is this Thunderbolt port right here. That's it. If that port fails, you're done. You have 3 other ports here, but they are not inputs. You only have 1 input. If that 1 input fails, it's game over. And I've had, I would say, about 50% success rate working on those boards or fixing those boards. Since I posted my first repair on this LG board maybe about 6 months ago, I've been getting those monitors in almost twice or 3 times a week. If you look online, that monitor goes for $1,299, Best Buy, or you can buy it from Amazon, or you can buy it from Apple. If you have this monitor and it lasted you more than 2 years, let me know. Leave it down in the comments. But based on my customers' experience, every single one of them had it for 18 months, 17 months, 15 months. Now, like I said, we only have 1 input on the board. And if that port fails, then you're not gonna see an image on the screen, or you may see lines or flickering or whatever the case may be. Let's take a look at the port. The port is soldered via the pins right under the connector, and those pins are soldered to pads on the board. You cannot see those pads, but we are able to take a quick look at the pins, and maybe we can push on those pins to see if they are solid or if they are making a connection. Now, I'm using the finest tweezer that I have in the shop here, and you can see how tiny this area is. It's very hard to get your tweezer in, and that's why I use the precision needle. I mentioned this in a couple of videos before. The precision needles comes in a package like this. We sell them. Those are made for us. And if you check the packaging under the microscope, needle probes, and the model number is NF Northridge-Fix.MP2, and you have one that has a straight tip, and those needles are super fine, and the other one is bent. Okay, so 2 probes, super fine. You can probe in microscopic areas, check pins on IC, LVDS connectors, so on and so forth. You can even use them for pad strips. You can press and hold the pad strip in place. You can clean and scrape off glue from edges of the IC, and just an overall handy tool to have when you are working with microscopic components. You have the straight one and the bent one. Let's use the bent, and let's see just how precise that needle probe is. Maybe we can zoom in so we can see if those pins are making a good connection. Very nice. And just look at how fine that needle probe is. If we push on that pin, look at this. The pin is moving. The pin is moving. The pin is moving. Not even a single pin is making a connection. And that's the problem with every LG 5K Ultrafine 27-inch monitor. Every single one. If you are buying this monitor, you need to think twice, 3 times, 10 times, or buy extended warranty, because that monitor will fail, guaranteed. And it's amazing how the whole board depends on this 1 port. And that port will fail from abuse, connecting and disconnecting the cable. The first thing I'm going to try is to reflow that connector down in place. We're going to apply flux and then apply heat from bottom of the board and reflow that connector back in place and see if the pins will be solid again. If not, then we're going to have to remove the whole connector. We're going to check on the pads under, and we'll take it from there. So there's no need to change that connector, and even if you want to change it, I do not have a replacement. So we're going to have to use either the same connector, or we're going to have to remove one of the connectors, one of those connectors, and put it here. But no need to do that right now, because internally, and when I say internally, I mean from here, the connector looks good, okay? And it's solid. even though you see that the shell is a little bit separating, but that doesn't matter. Now to heat up from the bottom, we're gonna have a problem. We need to heat up from right over here. That's back of the board. We need to apply heat here so that the connector on front of the board solder will loosen up and we can push down on that connector so all the pins make a good connection again with the pads. But the problem is we have two plastic connectors. How can we apply heat on back of the board if we have a plastic connector here and a plastic connector here? This one is a bit far because I need to apply heat here, but this one is close. So what we're gonna do is we're gonna remove this connector so we can safely apply heat here, reflow the connector in the front, and then I can put this one back. And we're gonna remove this connector by using low melt solder. The magic of low melt solder. We need to apply low melt solder on the front pins and on the sides, and then we should be able to easily remove the connector. I'm using a conical tip, and maybe that's the wrong tip for the job, but since I already have it, let's try it. And we're going to apply low melt solder on the side. And we're going to apply low melt solder on this side also. And there is no more low melt solder left on the tip, but no need to fear. All right, so we just removed that connector. We did not apply hot air. We did not do anything unsafe. We just used low melt solder. We're gonna clean low melt solder that's on the board, and we're gonna apply leaded solder when we want to solder that connector back. And let's get rid of the glare. And people are asking, when are you gonna post the video on how to remove glare when you are working with shiny objects? The video will be posted soon, I would say in about a week. Let's clean those pads. Right, now let's flip the board, and I'm gonna have to move the microscope all the way over the connector, and we're gonna heat up from the bottom. So let's bump our heat all the way up to 500 degrees Celsius and airspeed all the way up. Maximum. The board is thick and it's gonna take a lot of heat to melt solder on the board, because you have to remember that the board itself must reach melting temperature of unleaded solder that's on the board for solder to melt and liquefy. We're gonna press down on the connector. Looks like solder liquefied, but I'm gonna press and hold. Press and hold. Press and hold. And I think that's enough. Keep holding. Let's wait until solder hardens and we'll check. All right. Let's check to see. We're gonna grab our bent needle probe. So right now, the pins are still moving, which tells me that we may have broken pads on that board. So right now we have to remove that connector and check to see what's going on under. If we find a lot of missing traces, then we're gonna deem it a no fix. It's not worth the repair. It's neither practical nor economically viable to work on it if we have a lot of missing traces under that connector. I've done it before on YouTube. You can check it. But we have to be smart on what to work on and what not to work on, what's going to waste a lot of our time and what is not. And even after fixing all the broken pads and missing traces under the connector, you may still end up with a board that does not work. And that happened to us many times before. And let's see what type of Hiroshima we have here. Look at this. Look at this mess. And that's the case with every LG 5K monitor that we've got into our shop. Actually, I've seen worse. I've seen worse to a point where all the pads are ripped off the board. But look at this mess here. And I can tell you from experience working on those boards, it's very difficult to run wires to the pads here because everything is so close to each other. And those ripped pads are very close to the ground hole, supporting pad that you see here, supporting hole, 1, 2, 3, 4. So when you run a wire from here all the way here, you are maybe about 0.1 millimeter apart from that hole. It's a lot of work, and like I said, even after fixing all those traces, you may still end up with a board that is not functional. So we're gonna deem it a no fix. I thought maybe if we had one missing pad, I will do it. 2 missing pads, I will do it. But half the pads are missing. And there's no way I'm gonna spend any time working on this. It's a lot of work without any guarantees. Maybe this video can be a lesson to everybody watching not to buy an LG 5K ultra fine monitor unless they have a spare input to that board. It's crazy. It's unbelievable. Or unless you buy extended warranty for 3 years or 5 years, then at least you know that your money will get you 3 years or 5 years and not 1 or 2 years. And that's it. We're gonna end the video right here. I hope you enjoyed it. Don't forget to like and subscribe, leave a comment if you have any questions, and we'll do something else in the next video.